Hi, welcome to Gooey.AI. I'm Ambika and I'll be taking you through a bunch of videos and guides to help you build your own copilot and test it in the field and get it ready for production. But before we start, I just thought it would be great for us to go through a bit about what is generative AI and how does it work with Gooey.AI's copilots and all of the things that go with it. This will be a quick run through of some slides and we will also do a small demo at the end. And in context of that, this is our agenda for the day. We'll understand how LLMs and RAGs work. LLM is large language models and RAG stands for retrieval augmented generation. We'll understand a little bit about what happens in the vector DB. We'll understand speech to text and text to speech, which are important user end requirements. And then eventually we'll figure out how to set up a copilot, add your knowledge base, deploy it on the web, and look at some other details as well, like functions, analysis, etc. We'll learn all of this through the course of our modules, but today is just going to be about the concept and a very basic idea of what the copilot builder looks like. So how does an LLM work? I mean, there's a lot of technical stuff around it, but the core is that the user puts a query in and the query uh, turns into a generated answer. Now, this could be anything like what is the capital of India? So it might say New Delhi. Sometimes LLMs tend to hallucinate as well. So if it's not trained on a certain subject, it may give me a wrong answer instead of saying, no, I don't know the answer. So think about it like writing a test question. You have to recall the right portion of the book based on that and give an answer. Sometimes when you don't know the answer, there may be a tendency to write something because it's a test question, but it may not necessarily be the accurate answer. So how does this work when we add retrieval augmented generation? First, the user's query goes to a knowledge base which has been indexed. This knowledge base may include many structured and unstructured data, like it can have text, PDF, links, web pages, CSV files, etc. So, based on those, relevant snippets are picked out of that knowledge base, and the LLM's task is to summarize those snippets and give the user an answer. So you can think about this like almost like an open book exam. So you have a test question, but the LLM has the opportunity to go through the books in front of it and give the right relevant answer and summarize it. And what is a vector DB in this context? Now we've been looking at this diagram where there is this little cylinder with which is vector DB. This is basically how all of your documents are indexed in a large context called vector embedding. This means that say you have a word like bunny, it will be mapped across several other words and it is given a indicative number based on that. So here you can see bunny is mapped to alive at 0.9. So the scale is from say 0 to 1 or sorry it goes into so here you can see that the vector DB maps the words to many other words and creates this kind of numbered embedding. So you will see here that bunny is mapped to alive, which is on a scale of say -1 to 1. So it's a 9, which means it's very close to bunny. Whereas bipedal is not so close because bunnies have 4 legs, but sometimes they can sit on the hind too. Whereas if you see hutches, it is not alive at all and it's almost close to a -1. So once that kind of numbering is embedded, the vector DB kind of charts each word around it. So if you think of this in context of a question that somebody might ask from a database, if you have a database of say WHO guidelines on pregnancy, if you ask a question which is specifically related to it by saying say how much weight should an underweight pregnant woman gain during her gestational period, so it's going to check for all the relevant words to gestational, pregnant, weight and try to bring out those aspects. However, if you ask a question which is not related to that particular vector database, which could be, say, what should be the father's hemoglobin at this time. Now, this is not related to those documents, so it's going to give you a, say, a minus rating in that. So, vector DB is really essential in bringing together what the user has queried, getting the relevant data from the documentation that we share with the LLM, and giving the right answers. And this is why we can use RAG or vector databases to make sure that hallucinations don't occur when users get answers. And how does this happen? We've just spoken about it. You can add your PDFs with diagrams, your instructional videos, documents, images, and they'll create this indexed embedding like we saw. And then, say, suppose you asked a query about a black bug on a plant, so it's going to bring in that right set of words and make a semantic similarity and give you an answer. Then we go on to what is text to speech and speech to text. So it's very simple. If a user queries something in audio or a voice note, first you need to understand what they've said, what language it is in. So you do a speech recognition and you also do a translation. And then from there, you transcribe it, and that transcription goes to the LLM for an answer. Once all of that happens, once the LLM gives the answer back, the user might want to hear the answer and not have to read it. So that text input is then generated via so that text input is then generated via text to speech models and gives a machine generated audio which can be delivered as a audio note back to the user. So let's look at it in context of this very simple scenario where nurses have a question about blood glucose. Sorry, let's look at it in this context where the nurse has a question about blood glucose. So how should I adjust the frequency of HMBG? The nurse has a problem. She asks the co-pilot and she gets an answer. So that's on the right, you see a screenshot of what that answer might be like. So user inputs the problem, the co-pilot searches the knowledge base, it summarizes it with the LLM, and there might be some special tools which it calls. We'll talk about this a little bit later. And then the user gets an output. So if I were to put this together in a diagram or a table, it would be something like this. That the nurse has a problem and the nurse asks the co-pilot. So this could be inputted as a photo, audio note, or a text. The relevant snippets come through from the knowledge base, and this include the conversation history that the nurse might have had about the patient or about similar scenario, and those summaries those snippets are summarized, and you get an answer which is in English. It gets translated back into the language which the user had. There is a text to speech there, and then in some scenarios there could also be a lip sync. There's also what you see here, what we call tool calling. We'll talk a lot more about this as the modules progress. But the core idea is that there may be certain API calls or database calls that you need to do, which don't need an LLM specifically, but needs to do a very simple code-based function. Okay, I think I'm going to cut this part totally. There's you may also notice here that we have something called tool calling. This is basically what we call agentic LLMs as well sometimes, but we'll talk about this later in much more detail as the modules progress. So in this context now, every section has a specific kind of model or a specific API that we can call. Now you can choose that based on the mandates of your organization, the ones that work the best, and it's important to notice that every section has some which are private APIs and some which are open source. So here you can see the speech recognition has Google Azure DeepGram, or there are other ones by Meta which are open source, or Bhashini which is an Indian one, or even Whisper which is open source. Similarly, for the vector embedding, we can use several tools, and for the LLM, and then eventually for the translation and the text to speech as well. So how do we set this up for ourselves in a Copilot? Quite simple. You choose the language for your speech recognition, so that if a user puts in an audio note, you have that language and model choice. Then you collect your knowledge base documents. The LLM needs to know where to get the data from to answer relevantly. You choose and also give the instruction to the LLM model that you've chosen. Then you can hook up various tools. We'll talk about this a little bit later. And then eventually for the output, what are the things that you might need? You might need a text to speech model. Maybe you have a video avatar and you need lip sync. And then obviously you also need to deploy it somehow. So that deployment can be through WhatsApp, IVR, or web. So this is how the Copilot gets set up. But as product leads, you may also need to make sure that the Copilot is working well. There needs to be certain evaluations and observability in place. So for that, we also have some various tools and methodologies to make sure that these evaluations can give you correct answer accuracy. You can also observe how users are using your Copilot.